This is a video of graphing quadratic functions in the discriminant. The warm-up is use the discriminant to determine the number and type of solutions for each of the following. The discriminant is b squared minus 4ac. This problem, a is 1, b is negative 6, and c equal 9. Plugging in into the discriminant, negative 6 squared minus 4 times 1 times 9, and then 36 minus 36 equals 0. When the discriminant is 0, is 1 repeated real solution. The second one, once again, you're using b squared minus 4ac. And a is 1/2, b is negative 6, and c is 16. And negative 6 squared minus 4 times 1/2 times 16. (36) minus 4 times 1/2 is 2 times 16 is 32. So that's equal 4. So there are 2 real solutions. So the discriminant is greater than 0 or positive, then there's 2 real solutions. The last one here, a is 1/3, b is negative 4, and c is 15. Plugging into b squared minus 4ac. Negative 4 squared minus 4 times 1/3 times 15. (16) minus 1/3 of 15 is 5 times 4 is 20. The discriminant is negative 4. And the discriminant is negative. There's no real solutions. There are 2 complex or imaginary solutions when the discriminant is negative. Slide 2 is just an information slide. The review of different forms of quadratic equation in the discriminant. The standard form of a quadratic is y equal ax squared plus bx plus c. The vertex form, y equal a times x minus h squared plus k, where h equal k is the vertex of the parabola, and a would be the dilation factor. The intercept form, y equal a times x minus p times x minus q, where p and q are the x-intercepts, and a, once again, is the dilation factor. The quadratic equation, x equal negative b plus or minus square root of b squared minus 4ac over 2a. So the discriminant is under the radical here. So if it's is positive, that means there's two solutions there, the plus and minus x. But if this is 0, then the only solution you're going to have is negative b over 2a, which will be a vertex of the parabola. And if this number is negative, I can't take the square root of the negative. That's why there's no real solutions. They'll be too complex or imaginary solutions. And then find the number and type of solutions by looking at the graph. So because there are two x-intercepts, there are going to be two real number solutions. Number one, there's two x-intercepts. Number two, there's just a vertex on the x-axis, so one intercept. Because there's one x-intercept, there's one real repeated number solution. In graph 3, there's no x-intercepts. There are no real number solutions. There are two complex or imaginary solutions. The rest of the slides, you have to find the parabola that fits the points, and then find the standard form of the parabola, and then type in the discriminant in the last box. So this one, if I use the intercept method, the intercept equation, it'd be x minus 2 times x minus 6. If I check that, it doesn't go through these 2 points. So in other words, this has to be wider. So in order to make the parabola wider, I'm going to use a fraction between 0 and 1. So I'm going to try 1/2 there, and that checks out. So if you don't want to guess and you need to do this, I'm only going to show this one time, and then you can do it for other parabolas if you like. So this is what we have. If we don't know what A is, and if we don't want to guess, then we need to plug in a point other than these two intercepts here. So I'm going to plug in 0, 6 here. So when y is 6, then x is 0. 0 minus 2 times 0 minus 6. And then 6 is equal to a times -2 times -6. And 6 is equal to 12a. Divide both sides by 12, we get 6/12 equal a. And then 1/2. And I simplify 6/12. So I'm not going to do that for every parabola. I'm just going to kind of try to guess what my a value is. So in this case, I guessed 1/2, and I was right there. So in order to find the parabola in standard form, you're just going to multiply everything together here. So the first thing I'm going to do is multiply x minus 2 times x minus 6. So I get x squared minus 6x minus 2x plus 12 by equal 1/2, and combine like terms in the parentheses. X squared minus 8x plus 12. And finally distribute the 1/2. 1/2 x squared minus 4x plus 6. I'm going to erase the rest there, delete the rest of this work here. So I'll have the answer in standard form now. But I would suggest just doing this on this, multiply this out on a separate sheet of paper, and then put the answer in the text box here and check. So I input this answer and it matches the answer that should be. All right, and then find the discriminant. So you're going to do -4 squared minus 4 times 1/2 times 6. So 16 minus 12 is 4. So once again, I'm just going to delete my work and put the answer 4 here. And check. So I input 4, the answer it should be 4, so I know I'm right there. And then number 5, since it's hard to determine this vertex, once again I'm going to use the intercept form, or intercept form. X minus 1 times x minus 4. That goes through the intercept, but it's too wide, so to make this more narrow, let's try 2. Well, that doesn't go through the vertex. Let's try 3. It goes through the vertex. So writing this in standard form, I'm going to multiply x squared, x minus 1 times x minus 4 first. So x squared minus 4x minus x plus 4. Combine like terms. And then distribute the 3, all the terms. You got 3x squared minus 15x plus 12. Now I got it in standard form, so I'm going to erase my work here. And my answer matches the solution here. And then the discriminant, my b value is 15, negative 15. Put that in parentheses, square it. 4 times 3 times 12. So we got 225 minus 144 is 81. And that makes sense because I have 2 real number solutions there. So I input 81 and the answer should be 81. This next one, we can use the vertex form here because we don't have the intercepts. So y equal x minus 2 squared minus 1. Whoops. I thought this was the x-axis, so this vertex is actually at 2, 3. So that's part's right. All right, and we need to make this wider because it doesn't go through these 2 points. So let me try 1/2 here. So that works. In standard form, I'm going to write this binomial down twice. So it's always a good idea to do that so you don't make a mistake. Y equal, and then I'm going to do 1/2, and then square x minus 2, so x squared is 2x. Next, combine like terms in the parentheses. Distribute the 1/2. And then finally combine like terms here. So my answer matches the one that should be. And then the discriminant. -2 squared minus 4 times 1/2 times 5. 4, 1/2 of 4 is 2 times 5 is 10. 4 minus 10 is -6. It makes sense because there's no x-intercept, so no real solutions there. Two complex solutions. So my input matches the answer there. Once again, we don't have any x-intercept, so I'm going to use the vertex form here. So the vertex is -3, -2. So x plus 3 squared minus 2. Whoops. It's facing downward, so let's put a negative there. All right, that works. The standard form. Negative of x plus 3 times x plus 3 by 2. The opposite of x squared plus 3x plus 3x plus 9 minus 2. So combine like terms in the parentheses. Next, distribute the negative. And then combine the -9 and 2. Negative x squared minus 6x minus 11. And then find the discriminant. So b is -6. Plus 4 times -1 times -11. 36 minus 44 is negative 8. And then when I look at this graph, once again, it doesn't cross the x-axis, so negative discriminant means I have two imaginary or complex solutions there. I input negative 8 and it matches what the answer should be. Here I could use the vertex form or the intercept form, so I'm going to start with the intercept form here. So x plus 5 times x plus 1, and this is facing downward, so that works. Multiplying everything together, x times x is x squared, x times 1 is x, 5 times x is 5x, 5 times 1 is 5. Combine like terms. So negative x squared minus 6x minus 5. And that matches the answer that's there. The discriminant, negative 6 squared minus 4 times negative 1 times negative 5. This is 36 minus 20, 16. And my input matches the answer there. So last slide says self-check exit ticket. This one's going to use the vertex form. So the vertex is at 1, 2, 3, negative 3, negative 4. So x plus 3 squared minus 4. And it's facing downward, so let's put a negative there. And that works. The answer in standard form. So the opposite of x plus 3 times x plus 3 minus 4 x squared plus 3x plus 3x plus 9 minus 4 and then distributed negative, and 3x and 3x is 6x. I get minus 6x minus 9 minus 4 and combine like terms. And then the value of the discriminant, -6 squared minus 4 times -1 times 13. -36 minus 52 is going to be -16. All right, so to find the solutions, I'm going to go back up here and do this. So I equate this to 0. You can do either one, but so the opposite of x plus 3 squared minus 4 equals 0. So the first thing I'm going to do is add 4 to both sides. And then divide by -1. Take the square root of both sides. And subtract 3. One I out of the radical. Finally take the square root of 4. So -3 plus or minus 2i. And if you do use the quadratic formula, you could get something equivalent. It might not look exactly like this. Or you could also divide through by a negative and then add 13 to both sides and complete the square.